Good afternoon to you all. I'm Kapil Oberai. Welcome to this session on recent trends in Geoinformatics. I'm a faculty at Geoinformatics department at IIRS. So in this topic, we'll basically cover few of the recent trends that we can encounter in the geoinformatics. So I will be basically starting with an overview of the geospatial technology and how does an IT and ICT has a role or impact into the coming up of that technology and being used in the geospatial domain. And then we'll see few of the recent trends in the geoinformatics. Now, talking about the geospatial or the geoinformatics is primarily a suite of various geospatial technologies from GIS, GNSS, Earth observation, along with IT and ICT integration is something we call as a field of geoinformatics, which deals with acquiring, storing, processing, analyzing, and visualizing the geospatial data. So the geospatial technology primarily, as I said, covers the technologies like GIS, Earth observation, scanning, and the positioning technology, primarily the global navigation satellite system. From the GIS perspective, again we have the clients could be our desktop, it could be web-based, and then it could also be using the power of cloud computing. Cloud-based interfaces or cloud-based applications are also now very popular. Now with the availability of the smartphone and the lot of mobile users, most of the GIS applications could also be accessed over mobile devices. That could be smartphones, that could also be the tablets. Now from the positioning technologies, so GNSS stands for Global Navigation Satellite System. There are also regional navigation system like NAVIC for India, and then it's primarily for navigation, locating, and also for the ranging and the timing aspects. Earth observation primarily provides us the synoptic coverage of capturing data on the Earth's surface. That could be done using the satellite-based remote sensing, and nowadays UAV and drones are also very popular, along with the aerial survey. And not to forget the ground-based instruments may be also related to scanning like LiDAR, terrestrial laser scanning, and also the radar-based instrument that provides the what we call all-weather data access capability. So once we talk about geospatial technology or geoinformatics as a whole, we talk about these all technologies when the whole suite of these technologies combining GIS with Earth observation or remote sensing and the GNSS along with IT and ICT technologies primarily comes under we define as a geoinformatics. Now the field of geospatial technology and geoinformatics in perspective is touching the life of the common man. For our everyday use, we are depending on the geospatial technologies. That may be either looking for the places of interest to visit or finding the shortest path. Even the e-commerce or our food delivery, the e-commerce platforms are all being driven by the geospatial technologies, and these applications are within the confinement of our palm of our hand, are available on the smartphone and really change the life, and they are part of our daily lives. Now if we talk about GIS technologies, so it goes back somewhere in the mid 1960s, and then with the advancement of the IT technologies, the benefit of the new technology development has also been incorporated into the GIS to further expand the capacity, the type of the analytical capabilities that GIS provides. Now GIS has really revolutionized many industries, and it's a corner, and it's like a is used widely across the various sectors, from infrastructure to environment, utilities, and even in the healthcare. Especially during the COVID-19, we have seen various use cases of geospatial technology, from identifying let's say the hotspot areas, even the application like Arogya Setu, which was being installed by most of the users to know about the let's say the identifying the COVID testing labs, and also to know whether there are any COVID positive patient within a vicinity. and slowly that app was also enhanced to support the vaccination and other things. So all was driven primarily based on the geospatial technology as a whole. Now, so as the technology has evolved, GIS has also make use of those technologies and also make the best use of this technology to expand the reach and also increase the capabilities of spatial analysis capabilities and the power of processing that such technologies provide, like cloud computing. And even with the coming of the IoTs or the Internet of Things devices, now it is possible that the various sensors that are installed on the field could be used for accessing or generating the data that could be received and analyzed on a centralized or on a centralized based machines. And with the coming of let's say the artificial intelligence, machine learning and deep learning, the GIS technology is being expected to go at much more rapid phase. Now talking about the industrial revolution, so the for industry 4.0 4IR that we talk about is primarily on the autonomous or the smart factory, talking about the such of technologies like cloud computing and IoT. So GIS is also making use of the advancement in the technologies to best serve the users and also provide more capability, increasing its usefulness by incorporating and making best use of such technologies. Now, so the first trend that we can discuss is on the artificial intelligence, machine learning and the deep learning. So artificial intelligence is primarily the simulation of the human intelligence processes, mostly by machines, especially we are talking about the computer-based systems. Machine learning, however, is a subfield of the AI, which is primarily focused on learning from the data and the use of the algorithms which can learn from the data and primarily imitates the way human learns and also improving the performances. Deep learning, as you can see from this infographic, is a subfield of the machine learning where it tries to mimic how the way the human learn, and here we talk about the neural networks for understanding the basic processes and primarily uses statistics, predictive modeling to process data and make the suitable decisions. Now there is a new concept of generative AI, primarily with the popularization of ChatGPT, which was somewhere launched in November 2022, wherein algorithms like ChatGPT that provides a prompt-based interface that enables user to create content, and content could be the written text or the code. It could also be visual like images and videos and also the audio responses. But as you can see from the right hand side is the artificial intelligence, machine learning and deep learning is primarily used by the data scientists, but this generative AI has now make it possible the applicability of this artificial intelligence that could be used by the developers and also the end users. Now just to understand the difference between the machine learning versus the traditional programming. So in traditional programming, what we do is we have a program, and in the program we feed the data, and the program actually contains the logic based on which we get the output. Whereas in the machine learning, we have a bunch of labels called as the data inputs, and we also have we have a feature, let's say the matrix, which contains of input data and also the output labels, and then based on that it is fetched to an algorithm. So machine here refers to an algorithm that it learns from the input and output relationship, and then it generates a program, and that program or that model that is generated is used for further inference on the new data. So compared to a traditional programming approach where we write the logic wherein the data is analyzed as per the logic to generate the output, here we let the machine or the algorithm learns based on our dependent and independent variables and come up with the model, and that model is used for inferencing on the new outputs. Now to talk about the difference between machine learning and deep learning. So as you can see from the figure here, in machine learning we provide the algorithms with a bunch of inputs called as the feature vectors along with the outputs, And then in machine learning, the experts are also required. So from the input, they need to extract the feature. Extraction is a very, very important aspect before the algorithm can use it for processing and generating the output. So the algorithm could primarily be for classification, or it could also be for the regression. So given, let's say, a bunch of inputs and we want to classify whether it is a car or not, then we have to give them the input samples along with identifying the various features that characterize that car. This is has to be done from the human perspective. So feature engineering or feature extraction is a very, very important aspect when we talk from the machine learning. Because primarily we are trying to build a relationship between the dependent and the independent variables, which in turn generates the output, which is whether we want to classify it as a car or not. However, in the case of a deep learning, this feature extraction is not need to be provided, but we need to give them the algorithm a bunch of inputs, and the algorithm automatically extracts the important features and then carry on the process of generating. It could be either the classification task or the regression task. So the basic difference between machine learning and deep learning is that in the machine learning, the human intervention in the case of identifying the proper features and extracting the features that needs to be given to the algorithm is required, and this is where the major effort goes in the machine learning. Whereas in the case of deep learning based algorithms, the algorithm learns and identifying the features, important features on its own, using the input data that we provide. Now, this I'm displaying a recent study that primarily summarizes what the researchers thinks about the AI and its role in the sciences. So this is a paper that was published in somewhere in September 23, and the Nature surveys conduct a survey across 1600 researchers, and it summarizes whatever their findings are, and it finds that the scientists are concerned as well as excited by this increased use of artificial intelligence in the research. So the figure here is showing that AI has now on the rise, in the sense that in the journal articles you will find more number of AI based papers being published, and has risen to over around 8% as per the Scopus database that they have referred. And initially they were primarily computer science based papers, but slowly and slowly, if you see from as the year is suggesting here on the below, other kinds of discipline like physical sciences, life sciences, social sciences, health and medicines has also picked up. So this machine AI is not a new technology, but obviously for understanding and making best use of this, we do require the computing and other resources. So over a period of time, the algorithms are being matured, and now with the availability of those infrastructure, now we are able to generate and make use of those algorithms and for our further science-based activities. The other finding that they have also find out based on this survey among the researchers was both the positive impact they feel and also the negative impact. So the question was posed to them, asking that whether the machine learning method, what do they think about the positive impact of AI in science. And as you can see from the result, so the people agree that it provides faster way to process data, more than 65%, and also they also agree that the speed of computation has also increased, and then it also saves researchers time or money, along with automating the data acquisition processes, and also it makes it possible to process new kinds of data. So based on this suggestion, you can see that the researchers are in a way are impressed by the role of AI on the research, because it is leading to the faster way to process the data and also speed up the computation, which traditionally will be taking a lot of time if you do on the manual or other basis. Now, from the negative impact, if we see, we can see that some of the remarks are that it could lead to more reliance on pattern recognition without understanding, because AI is also think in terms of a black box, so people are maybe not be having an idea of what actually is happening behind the scene. Other thing could be is the related to the biasness or discrimination in the data, and also the doubt regarding the it makes a fraud doing easier, along with ill considered use leads to the irreproducible base research. So these are the findings, and I have put this paper just to highlight that over the period of time, this AI technology has been utilized, and both in various domains, and then has been going on to deliver good results. Similarly, there was questions on the on related to the generative AI, where the question posed was, where do you think the generative AI may have a negative impact on the research? So the most of the people agree that it may leads to the proliferation of the misinformation. Also, it could make doing plagiarism easier and harder to detect, and then it also could leads to mistakes or inaccuracies into the research text. So these are some of the, let's say, the issues or the negative side of using of the generative AI. But if I come to the positive side, so as you can see here, they agree that it could help researchers who don't have English as the first language to carry on the editing or translation processes. Also, near to 40% also agree that it could make coding easier and faster. Similarly, on the positive side, they also agree that it could help in summarization of other research to save time in reading and etc. Because these technology can do it for you, and we can save time and effort. Similarly, the speed towards the administrative or let's say the monotonous job or administrative task could also be somehow automated using such technologies. So the point I'm mentioning this article, I request you can please refer and read this, because they are good findings, and you'll find it really fascinating to read this whole paper. So the aim here I'm highlighting this paper is to put that yes, AI is here to stay, and just like any technology will have a positive and a negative impact. But if you look from the positive side, this is really helpful in maybe automating most of the processes and also helping the life. And then carrying out the research processes. Now, from the geospatial perspective, there is also a term coined as a geospatial artificial intelligence, and then the geo AI is primarily being talked about as scientific disciplines that combines the innovation in GIS or the spatial sciences along with artificial intelligence method, primarily machine learning and deep learning, along with other technologies like data mining and high performance computing to extract the meaningful information from the spatial big data. So as you can see from this figure here, so Geo AI is primarily an integration of various technologies like geospatial, artificial intelligence, and also the imagery coming from the Earth observation. And some of the popular applications areas of Geo AI include object detection. It could be detecting moving vehicles or the, let's say, objects like trees. Similarly, classifications like pixel-based classification, that could be land cover classification, and also identifying the building footprint kind of exercises. That could also be the digitization of scan maps, something covering under the category of digitization, or also it could be change detection based for carrying out the change detection studies related to land use land cover changes, also identifying new buildings, and has potential use in disaster and other areas. So Geo AI, we are primarily focusing on our geospatial domain, where we are trying to use the AI and ML based algorithms on our geospatial data, targeting various applications related to object detection, classification, and other change detection types of studies. Now, ML algorithms have capability to primarily extract the meaningful information from the remote sensing based data, and also helps in automating the analysis processes in towards interpretation and proper utilization of this geospatial data for various studies. It could be a segmentation, it could be classification, change detection, and even could be also spatial modeling. So ML algorithm has really could be quite useful in most of such applications related to extracting meaningful information from the remote sensing based datasets. Now, deep learning is a subfield of a machine learning that focuses on basically using neural networks consisting of multiple layers. The deep in the word means there are multiple hidden layers or multiple layers that is used for primarily learning based on the data and generating the results. Now, the deep learning models are primarily used for automatically learning and making the intelligent decisions by primarily extracting the data, and it is done in a hierarchical representation where the first layer learns the higher level representation and coming to the final output generation. Now, deep learning can find very useful cases in for various studies that could be in the domain of image classification, could be identifying the objects, could also be in the domain of segmentation, image segmentation, and also you will find various studies regarding the use of deep learning for image fusion. So in the bottom I have given one good reference that you can have a look for. This is a good review article that mentions some of the applications and nicely summarizes the applications of deep learning that you can find. So from the AI, now the other the trends that you can also encounter is towards the use of the 5G networks and also the Internet of Things and how they are related to the GIS. So Internet of Things technologies primarily connects objects that could be sensors, could be devices to the internet, and then that can collect data and also exchange and then could be transmitted over the internet to a central location for analysis. The IoT applications in GIS is primarily enables collecting, analyzing, and also visualizing the geospatial data coming from the on the ground. And you can see there are various applications of IoT-based smart applications from the health sectors to industry, even for the transportation, and also from the home automation types of solutions. Now, what has enhanced the role of IoT is with also the coming of the 5G kind of a network, which provide ultra high reliability with low latency, which is very critical for the mission critical control like healthcare and other sectors. And also it has enhanced the mobile broadband in the sense more that it has a very high data rate and also allow multiple devices to connect at the same time, and also with the coverage enhancement. Now 5G is primarily an extension of the 4G, wherein we have the faster data rates and also the advantage as I mentioned about the reliability and the low latency, and also enhanced mobile broadband access. So the IoT primarily enables the users to collect data from these smart sensors, and also these sensors and data that is coming could be analyzed and could be used for either monitoring and also taking informed decisions on time. That could be simple, let's say from the smart health perspective, could be a device that is monitoring the pulses or the BP, and then it could be automatically in case of any abnormality the information could be passed submitted to the doctor, and he could take informed decisions at the right time. This could be also in the case of a transport where the health of the vehicles could be monitored, and in case so the preventive maintenance could be done pre-hand instead of waiting at the last moment. So the IoT has various applications when we combine with the power of GIS from various applications area ranging from urban infrastructure to transportation to disaster management to the healthcare. And this paper I have mentioned provide a good survey of the integration of IoT with the GIS and talking about the various applications. So we talk about the agriculture, let's say if we take an example, then the role of GIS could be minimizing the soil erosion, also simulating the effect of the climate change. But with the role of IoT, so we can measure the agriculture factors from the ground, and also maybe we can sense and monitor the small changes that are happening. So in the real-time basis, we can improve the effects by analyzing this data that is coming from the fields. Similarly, from the healthcare perspective, it could enable us to monitor the patient status remotely, and also maybe evaluation of the medical instruments and so on and so forth. So basically, it is primarily enhancing the monitoring system from the patient and the let's say the doctor in use case environment. Similarly, for the disaster management, though the role of GIS could be limited to making maps, mapping, and also simulating the effect of disaster on the people and the other aspects, but the IoT could help in collecting the real-time information from the ground and could help in enhanced management so that we could best address those solutions. So IoT is and with the combining with the power of GIS could really help, and then maybe best use of both technologies to serve the users. This could be used in various scenarios from urban to transportation to healthcare and various other sectors also. The third the trend that we are also discussing here is related to the location based services, and I want to tie it up with again with the 5G network. And also now, because of the availability of the high speed network and the reliability and so on, it is now possible to have the augmented and also the virtual reality. But first, let's try to understand the meaning of the location based services. So location based services is the intersection of primarily three technologies: GIS, internet, and the mobile based devices. So location based services primarily refer to providing location aware services based on the current user requirement, and serving the information that the user is looking for based on his surroundings. So location based services has various use cases. Or your e-commerce site from the delivery platform perspective are primarily using this to send the products to the end users. All the routing platforms are primarily using this the concept of location based services to serve the users in a better way. However, with the availability of these 5G networks, now it is possible to enhance the location based services to other sectors, talking about augmented reality and also the virtual reality. So these two technologies, AR and VR technologies, it provides new avenues for exploring, analyzing, and understanding the spatial information, and also for proper decision making. The term augmented reality, as the name suggests, it combines the real world environment with the computer generated overlays to provide an augmented view of the reality that the user is standing or maybe at that location. So the augmented reality primarily superimposes the digital content based on the user's surrounding. As you can see, a classic example could be when you go to a shopping, let's say the shopping mart, then you can open your mobile app which is augmented reality enabled, and then as you point out over the shelf, then you can identify which are the, let's say, the products which have sale, or it could also help in other various other aspects. It could also be that the digital content could be superimposed on your, it could be you can wearing some headset or a headgear, and then the information are superimposed that is coming over the internet that could is displayed on your mobile or handheld tablet based devices. Whereas the virtual reality, as the name suggests, here we are using the term virtual, which primarily takes the user, it could be the physical environment, could be a simulated environment, and then it primarily immerses the users in a computer generated environment by replacing with the physical surrounding. However, in this case, the user needs to wear the handset, and then the environment could be a simulated environment. It could be realistic, or it could also be like the physical surroundings. And these AR and VR applications has huge potential in various sectors, that could be tourism, education, healthcare, advertisement, and also for the entertainment. So again, with the coming of the 5G networks, these kind of applications will be more available, and then the user will be able to make use of these applications for various in the various sectors. So the prime difference between augmented and virtual reality is that augmented reality, as the word suggests, is primarily uh, augments the current physical environment and superimposes with the digital content, and for that it could be made use of the mobile devices or the tablets. And then for the virtual reality, it involves wearing of the handset, where the user could be brought into a simulated environment, that could be physical or could be hypothetical, and then a different computer generated environment wherein he can observe and see different scenarios, and quite useful for various healthcare and tourism related applications, has huge potential. Now, location-based services in itself is a huge market. As I said earlier, most of the companies are running purely on those location-based services, right from, let's say, booking of our cab to the vehicle tracking system. All are primarily driven by this location-based services. The next trend is towards the having a digital twin. This is more from the 3D perspective. So the digital twin is primarily a virtual replica or a representation of the physical objects that we are representing in the digital realm, and it primarily combines both the real-time data and along with the model simulations and the various analytics to provide primarily interactive and dynamic content to the actual physical, let's say, the entity that we are representing as a digital twin. Now, this is different from the static 3D models that we develop, and here I want to just emphasize on the infographic that you can see here that generally the 3D models follow a various level of details. It could be a simple footprint, or it could be a block model where we extrude the model based on the height, and followed by the LOD2 where we could have the course exterior, only the roof part that you can see. Similarly followed by LOD3 where you could have the windows and other facade related aspects, but whereas in the LOD4 we can also map and monitor and then represent the features of the inner objects. So from the footprint all the way to the LOD4 is primarily how the objects are represented, but in coming to the digital twin, in comparison to only making these 3D models that are primarily static, these digital twins are primarily linked to multiple data sources, and they are also updated as and when the situations are changing. Now, these digital twins nowadays are very popular from the smart city kind of studies project, wherein could be used in various scenarios. I have given one mentioned here. These digital representation of the city infrastructure, for example, from the municipality perspective, are being used to monitor and simulate the scenarios like related to the climate change events and also the flooding events, and then we could identify how much submersion, or let's say how much people will be affected in case the flood event happened and the water rises about a particular level. The good thing about this, as I said, is not a simple 3D static model. It receives data from the IoTs which are connected, and as and when the things changes, the physical model also is also being replicated and represent the same phenomena. So this is again one more thing that the people are also working into, talking about the digital twin. The next trend that I want to talk about is related to the spatial big data and also the analytics part. Now, big data, as the name suggests, we are not talking big in terms of the volume, but the definition from representing the big data, we are primarily characterizing based on the V's, which talks about not only the let's say size, which is the volume, but also the variety, the velocity, the veracity, and the value, and there are others V's also people are also adding into those. for understanding the variability of the data. So the moment we talk about big data, we are talking about data from varied sources that are somehow difficult to process by traditional methods. Uh, uh, let's say a relational management system or a traditional way of processing the data. So the complexity here is not purely from the volume perspective, but what makes the difference is the different types of data. So so the structured data is something we are well accustomed to and could be handled if by the traditional mechanism. But the the big data, also the other types of data that are we encountered is the semi-structured, and also sometimes it does not have any structure. So it becomes difficult to somehow fit into a relational model, and which makes it really difficult to make sense of this data. The other V, which is very important, is the speed at which the data is generated. For example, it could be the data coming from the IoT devices, or it could be data coming from social media feeds, and which is again a various challenges. The other way of looking at the data is nowadays there is a huge amount of data that is being generated. So if I talk about the various sources of data from the big spatial data perspective, so we have the data coming from the satellite imageries, which is one sources of data. And you can, as you know, that there are many satellites which are collecting data, not only let's say the Indian remote sensing satellites, there are satellites from other countries which are also collecting the data. The other sources that is contributing to this big spatial domain is the data that is captured through surveying and mapping, or it could be other legacy data that is with the surveying organization. The other sectors that are also contributing to a huge amount of data is the location based data that is being captured. That could be from the mobile based devices and other aspects. And also this nowadays the social networks or social media is also one more form of data generation, which could also be geotagged, that is generating the data. And we have also discussed previously that the Internet of Things, where there could be a lot of devices which are also monitoring that at the field level. That could be pollution sensor, that could be temperature sensors, could be other kinds of information that has been coming. And then from the social media perspective, as I said, there are various kinds of social media platforms where the people are also contributing data, and such data are very useful for having a ground situations, understanding of the ground awareness and situations. And in many case studies you will find that people have also make use of such social network data like Twitter data for understanding the traffic patterns, and as also useful in the disaster management, understanding the, let's say, the sentiments regarding the various products and services. So various literatures you can find in those domains. Now, what makes this big data very challenging is that we need to collect the data and also process the data as it flows. And since we are not talking about one type of data, there could be various types of data from different types. Some could be structured, some could be unstructured. So how we could process it, store it, transform it to fit into one need, and finally use it for analysis, which could be in the form of dashboard based report, or also could be ad hoc based queries. So the traditional way of understanding and managing this data will not work. Hence, there are few newer data management strategies has come, and then two popular frameworks here are called as the Hadoop and the Spark based framework. So Hadoop primarily has two components. One is the HDFS, which talks about the distributed file system, Hadoop distributed file system, which allows the data to be stored in cluster environments and in a fault tolerant way, so that in case one of the node goes down, the data are still available. And the second component of the Hadoop is called as an MapReduce. So MapReduce is primarily a programming paradigm which allows to process a large amount of data, and it divides them into two stages known as the map phase and the reduce phase. And Hadoop also has a whole bunch of tools to work, and is generally called as a suite again from the Hadoop ecosystem perspective. So you have various other tools like Yarn, Hive, Drill, maybe the Zookeeper for managing the resources, Yarn like for allocating those resources. The and then from the spatial data perspective, there are various solutions that are also targeted specifically for the spatial data. One of them is called as the spatial Hadoop, which allows you to analyze the spatial data. It also supports the various spatial data types like point, line, and polygon. Also the indexing and also the writing of the queries it does supports. You can visit this website on the spatial Hadoop, and there are good tutorials are also available to how to get started using such solutions. However, Hadoop is primarily used for a batch processing related task. So another solution is called as in Spark. So the Spark primarily allows in-memory processing, and Spark does not require any data sources. So it could connect to the any data source like HDFS, or could any columnar NoSQL database could also support. Spark has two components. One is a Spark core, which provide the necessary libraries and also support the other use cases like Spark streaming, the support for machine learning libraries, the graphic processing through GraphX, and on the top it also supports the structured data processing using the Spark SQL. Now, compared to the Hadoop based framework, wherein we are primarily doing the MapReduce programming in Java based language, the Spark allows us to write our applications in multiple languages, that could be Java, Scala, Python, and R. So it has a more choices, and it is compared to Hadoop, it is faster because it does the processing in memory. And then if you look at it closely, that it is also called as a unified computing engine, in the sense that unlike Hadoop, where we need to install different libraries for carrying out the task, like if you want to do machine learning, then we have to install the Mahout library, whereas in the Spark, most of the use cases regarding stream processing, machine learning, graph level processing, also the handling of structured data could be handled natively in the Spark language. Now, from the big data perspective, there is a limitation when we talk about the relation database system, because they are primarily means for vertical scaling. And also you can only store data in a relational model where the data is organized in the form of rows and columns or tables. But if our data is in a form of let's say a JSON key value pair, or we are trying to represent the relationship in the form of a graph network, so such kind of data could not be natively stored in a relational model. So there is a new system called as a NoSQL database. The term NoSQL does not means that it does not support SQL as a query language, but it is a way of indicating that it does not confine to a relational model. And there are four variety of such NoSQL databases: the columnar, graph, key value, and also the document. So MongoDB is a one good example of this such systems. So the big data, again, if you since on this aspect I have talked about the complexity of the data, and also how to make sense of those data, considering the variety, the speed at which data is coming, and also the huge volume perspective. So the traditional mechanism may not be the way to go. So we required some new solutions wherein we are able to take the advantage of a cluster environment, and the problem could be divided among the nodes and could be processed in a much faster manner. And also there are different types of databases to enable to store such kind of varied data also. The other the trend that we want to talk about next is related to the cloud computing. Now, cloud computing we can think in terms of as a utility as a service, where we are using the resources not on premises, but a cloud provider, which could be accessed on demand and could be used. It is similar to what how we have an analogy of using of the electricity in our home. Now, the cloud model primarily provides three kinds of service model, which is infrastructure as a service, second is a platform as a service, and fourth is the software as a service. So in the infrastructure as a service, as the name suggests, we are depending on the cloud provider to provide us the necessary infrastructure. That could be the network, could be storage, and could also be the processors. So it is similar to how we have a physical system on the premises, but here we are able to use such resources over the net through a cloud provider agency, and on the top we could build our install our the operating system necessary libraries to build our applications, and on the top we could build our necessary softwares using the data sets that we have got. The next type of service model is called as a platform as a service. Here the vendor provides not only the infrastructure but also the necessary operating system and the runtime libraries, and our role is only to maybe install the softwares and the data and make use of them. So one example could be you could ask for the cloud provider to provide Hadoop as a managed service. So in that way, the user need not to, let's say, the manage the or configure the whole physical hardware, install the necessary library to run the Hadoop cluster, but and use it as a managed service where the user is only trying to make use of the Hadoop cluster to solve his problem, and writing only the let's say the MapReduce code, and elevating himself from both the maintenance of the hardware as well as configuration of the whole cluster. The third is a software as a service. Example could be the usage of the various applications like email service, where it is like a subscription based service where the vendor takes care for all the tasks related to the management of the server, to the necessary operating system, and the underlying software, let's say the email service, and user is only using it from their desktop or the mobile devices. Now the characteristics of the cloud computing, it primarily provides on-demand self-service. So the user can, is based on the requirement, can provisions let's say a virtual machine or resources on their own. They don't require a dedicated service engineer or a network engineer to help them, and most of the cloud service provides a good interface through which all the cluster management tasks could be done at their own, and also provides the broad network access, which means these services could be accessed over the network through a mobile or a desktop based interface. And we could think the cloud services as accessing of those resources among the pool of resources that the cloud provider is providing to various users, and we are making use and utilizing the resources from the large pool of resources that the cloud provider has. The other advantage of or the characteristics of the cloud computing is it provides rapid elasticity. So in case we are running an application and then we want to increase or expand the capabilities, so based on the requirement we can provision the virtual machines and then configure it instantly. Compare this to on-premises where it will take a sufficient amount of time to procure the hardware, configure it before you can actually use it. Other characteristics of the cloud computing, it does provide a measured service. So we are only billed for the amount of time that we are using the resources, and the usage could also be monitored by the various reports that could be generated towards the utilization. Now from the geospatial perspective, a very good example is the Google Earth engine, where it provides the necessary data along with the algorithms and the coding environment, so the user can concentrate on more on the data analysis part. Now so these Google Earth engine kind of applications is leading to a paradigm change towards the normal way of processing on a standalone system, where the user will primarily first go to the data portal, download the data, and then carry out the various steps of pre-processing analysis on the local machine before he can generate the product which he can deliver to the end users. So these cloud-based platform, what they do is they provide the necessary data sets in an analysis ready form. So all the pre-processing steps are already taken care of. The user can log into such system, can access the data along with the tools. So think in terms of the data, and the applications are running at the place where the data is. So there's something called the concept of data locality. So I am not worried about downloading the data, because the input output cost or data downloading cost is a huge has a huge consideration. And if suppose the data and the algorithms that is running is resides on the same place, so the it will run much faster. And also not to forget the power of the, let's say, the Google based cloud infrastructure, which will utilizing multiple nodes, so you can process such information very fast and able to generate such maps where here is showing maybe the glacier retreat, could be urban growth and various other sectors. Now the cloud infrastructure could also be very useful from the big data perspective, in the sense that it, as I said, it could also provide a kind of managed services related to the various configuration like Spark, or maybe let's say the Hive. All those resources could be already built in, and the various data sources, talking from the big data perspective, like the various data source coming from either remote sensing, GIS, GPS, social media, could all be integrated, and the various analysis towards data mining, maybe scenario simulations, and various geospatial domain studies could be done, like climate change studies, land use, land cover studies, and the value, which is the fifth V of a when we define big data, could be either through the decision support, or it could be publications and other aspects. So cloud computing is also very useful from the big data perspective, because not all users will have those necessary infrastructure in place for configuration of those maybe the cluster environment and their management. And this is where the cloud based infrastructure could be very useful to speed up the process, so that the user can focus more on the analysis and the results, instead of worrying on management and also troubleshooting, and also taking care of those resources, the updation, the security, and all those aspects. So in that way, the cloud computing is really a boon when we talk about from the managed service perspective. Now the cloud could also be one minute. So the cloud, there could be uh, 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 multiple types. It could be a private cloud. It could also be a public cloud. So the public cloud means the resources are shared across multiple users or organizations. In the case of private cloud, the same cloud setup could be done only for a particular organization perspective. Whereas there are also possibility of hybrid cloud, which means that some data could be there in the private cloud, whereas some data could also resides on the public cloud. But only thing is, if you are having a dedicated private cloud, obviously this cost factor also has to be considered. The other technology that I want to talk about is the call as a blockchain technology. Now, blockchain, as the name suggests, it is the term has come because the data is stored in a chain of blocks, and is primarily a distributed and also immutable ledger that facilitates the process and recording of transactions and assets. Now, this is a very useful technology coming from the cryptocurrencies, but it allows to store the data in a decentralized way, and could be very useful for storing our land records, health records, and other aspects. So some of the features of the blockchain include the decentralization. So each member of the blockchain structure has access to the whole distributed database. So it is not stored at one location. Another thing is, it is immutable. So any record made in this cannot be changed or deleted. So we can only add a record. It can't be changed, or it could be deleted. And it works on the principle of a peer-to-peer network. So each computer primarily acts as a node for sharing the information, and there is no central server which is managing all the resources. Another important thing is, the user identity is also hidden, and all the transactions are primarily transparent, in the sense that transactions are registered in the blocks and they are published openly in a distributed ledger. So it is not a centralized based ledger, but all that informations are distributed and could be managed. And it has a huge use case, as I talk about, from while maintaining our records, data security aspects, and could have a useful in our land records, health records kind of information. This technology is finding very useful nowadays. Now, talking from the internet GIS perspective, so I want to here mention that the GIS has also evolved from the mainframe days to the desktop to the web, and now moving to the cloud interfaces. But from the internet GIS based perspective, we are also moving away from the pure visualization of the maps to the nowadays more analytics and dashboard, and also on the fly processing that the user is moving towards. So the initial days, if we are confined to the pure visualization of the layers, so we could develop such web portals where the various layers regarding a particular study area, that could be thematic data and other various kinds of base maps could be overlaid, where the user can do query and other things, was the first initial days where we used to just visualize. But nowadays people are also looking for this dashboard kind of interface, which primarily provides all the information that the user needs on their fingertips, basically all the key parameters that they're looking for. And we have find that such dashboards are very popular during the COVID times. It started with this John Hopkinson based COVID dashboard, and this idea of this dashboard was maybe you can see that it was done both at the WHO levels and also at the various countries, and also that the state levels. All those dashboards were created. The good thing about having this geospatial dashboard is that it provides a single synoptic view of the various information that we are looking for on a single page. For example, here we can see the distribution of the, let's say, the COVID situation along with the total confirmed cases, and you can see the statistics country wise. And as I zoom in and zoom out, those details will change. So this provide a good information on a single page, where we can get all the desired information that we are looking for. And this is what the decision maker is also looking. So instead of maybe querying on the individual layers, so this provides a good coverage of the information that could be available instantly, and the informed decisions could be made. So this is one study done by our PG diploma student, where the dashboard regarding one Matara district of Sri Lanka was done, wherein the various layers would be input, and then as you zoom in and zoom out the map, the information regarding the employment status and other, the like say the demographic or other male and female number of people could also be changed the moment we zoom in and zoom out on the various provinces and other administrative regions. So again, the point is that to instead of giving different layers option where the user can individually query, for a decision maker, he required all the information to be available at one go, where he can interact and maybe arrive at the information that is looking. One more example is this, let's say the crime based dashboard, where the information regarding the distribution of the crime, the major the types of crimes that are happening, how they are distributed, which locality has more. So you can see it primarily makes use of the charts and figures to convey the story instead of giving them tabular information, and they are highly interactive in the sense, based on the user requirement, he can drill down and then look for the information that is it is looking for. And then such dashboards are very popular for, especially for the decision maker, where he wants to know the information, how the change situations are going on the ground, and he can narrow down or have a high level view. All the information that is required could be accessed from this one application. Now from the online processing perspective, so we are aware of the various OGC standards like WMS or Web Map Service, which is primarily for visualization, but one more standard is called as a Web Processing Service, which the aim here is to expose and provides algorithms as in services which could be accessed to the end users. And then it also exposes the same interfaces, which is get capabilities, describe process, and execute is a standard through which the algorithms could be executed, and the these algorithms resides on the server side, and the users are only interested to access them, provide the necessary data. The whole processing happens on the server side, and user can get the details. Here I'm showcasing one example where of providing clustering as a web processing service. So here the algorithms on the DB scan was implemented as a WPS or a web processing service, where the user can access it from their web browser. So the user needs to upload the locations of the crime events, and then we are making use of this open source PYWPS web processing system, which through which we have implemented this DB scan algorithms, where the points are clustered on the server side, and the users is primarily returned a KML file as an output, which he can visualize and see the various hotspots and other details, and he can overlay them on various on some web mapping sites like Google Earth or other applications where the KML file could be opened. So here the user need not to be worried about the actual working of the algorithm and its internal intricacies. The user only needs to provide the necessary data. In this case is the location of the crime, and then all the processing is happening on the server side. And also it elevates the user from maybe having an understanding of the GIS softwares to learn and handle those things. The all the effort towards carrying out a task, in this case a clustering, could be handled on the server side, and the user can only be interested in submitting the information and also interpreting the results, so that we can focus more attention onto the end use, which in this case is identifying, let's say, the crime hotspot. So this the web processing service is a standard which enables performing online geoprocessing, where the user don't need to be aware of the GIS tools, and also make you use this functionality over the internet without having understanding of the underlying algorithms also. Now here I just want to maybe cover one study where we have integrated the the sensor data, which is primarily on related to the traffic sensors, along with the geosocial media data for carrying out a big data base analysis. So the study aim was to primarily integrate the voluminous structured sensor traffic data along with the let's say the unstructured crowdsourced data coming from traffic, to identifying the traffic patterns and the historical trends. So here we have make use of this of the traffic data, so which is coming from the sensor, which primarily comes in an XML format, and then it follows through a series of data pre-processing steps, where we are cleaning the data and also filtering on the lane wise. And we have also aggregated the data on a temporal, like 1 minute interval we have done. Similarly, the data coming from the Twitter we are also utilizing, because these sensors were only installed at the few locations but not at all the locations. So by using the data that is coming from the Twitter, where people also talk about the traffic situations, was used to somehow fill the gap and also complement the data that we are capturing from the ground. Now for extracting the data from the Twitter, what we have done is we have used some keywords. So this was done in the Dehradun. So we have put some keywords like Dehradun traffic both in Hindi and English, so that we are able to extract those tweets from the Twitter. Now in Twitter there are there's a possibility of receiving a geotag tweets if the people have done that. In case of the non-geotag tweets, what we have done is we have used some the online geocoder to geocode them based on the, let's say, the place names and other aspects, whereas the geotag tweets were directly used for further analysis. So the tweets that were received, we use the sentiment analysis method for classifying them either positive, negative, or the neutral, and also we also done a classification on the to it, we classify them based on the naives based algorithm that we have used, and we have classified them into 7 classes. So either the people are talking about the, let's say, if we're tutoring, that could class belongs to, it could be related to accident, congestion, they are reporting about congestion or some construction on the road, or diversion, or weather related information, or it could be other information. And then also, based on the our data coming from the sensor, we have built a congestion model, which is empirical model, which uses various parameters related to the density, speed, and the road capacity. And then we have classified them as a high, medium, or low congestion models based on those empirical models. So the data coming from the sentiment analysis also for the classification was fused based with the empirical model based on this, and then we are coming with the final congestion class. And then, as I said, the data from the Twitter and the social media platform were primarily used for understanding the traffic situation, also filling the gap for the missing segments, and that data was stored into our MongoDB as a NoSQL database for both real-time and historical trends, and that we are monitoring on such WebGIS based dashboards. So here you can see that this study primarily combines it's a big data aspects, the internet GIS based things, and also the machine learning aspects, along with the big data of storage and processing perspective to arrive at a situation here which is more about visualization and analysis of the traffic trends, combining data both structured and also unstructured. Which also brings us to the final example that I want to talk about is that nowadays the people are moving away from more towards a solution oriented, and then from the decision maker perspective, what is looking for is an integrated solution by combining all those technological aspects. Let's say in the case of a disaster situation, so the various data sets from various sources could be collected. It could be from the Bhuvan, from MOSTEC, from ISRO, and other sources. Could be accessed through the various data access protocols and APIs, along with putting them under a decision support system with the utilizing data from the local, also from the community, and also incorporating the local knowledge, and also the knowledge from the expert. It could be the coming of the complete decision support system, maybe implementation of the, let's say, analytical hierarchical processing HP techniques or other techniques for the multi-criteria based analysis, and then we can derive the results on the fly, and that could be helpful for various scenarios. It could be for the disaster management plans, for alerts, advisory, and could also be converted into map services that other people can consume. So for arriving at these geointelligence applications, the technology involvement, the role of ITs are very important. So the various data sources will have a different format, they will have different storage or maybe processing requirements, but could be accessed, and from the decision maker perspective nowadays is looking for more from a solution perspective, where something could be given to him, so the various simulation of the scenarios could be done and the outputs could be generated. So as I said, from the end user's perspective or the decision maker perspective is ultimately the solution, and the underlying technology could be cloud, the big data, or the various underlying blocks on which we could build such applications. But ultimately the goal is to serve the end users by making best use of the various technological trends that are happening, and so that we are able to serve the user in a better way. And finally, I want to talk about the trend which is also the usage of the free and open source softwares, because they offer various advantages compared to the proprietary software, because there are no software cost or the licensing restrictions. And then if you look closely, the various types of application that you are looking for, like from a desktop to a web based, I talk about the server based processing, all those libraries are available, and they are quite robust from the production utilization perspective. So if you are looking for any types of tools, that could be desktop, from a web-based, from a map servers to the STI-based development that you're looking for, or WebGIS server environment, you can find a suitable solution under the open source domain, which does not have any restriction on the usage and the other aspects. And now for to how to get started on this open source journey, let's say if you're not taken one, so this OSGeo Live is a good place to start with. It provides all the open source softwares, and it can come in a form of a bootable DVD, or you can also have a virtual machine created, and you can also burn it on your USB drive also. So you don't need to install it, all the various software. Suppose you want to see and compare the capabilities of various software or see them working, then this is a good way to start, wherein all the softwares come pre-installed and you can try and use the softwares without need to configure, download and install and other things. So those who want to maybe explore some new open source software, I suggest that you can visit this or download this OSGeo Live DVD, and then you can try and use such softwares. So with this I will close, and then I will wait for your question.